Hey pre-calc students, welcome to today's lesson on solving polynomials by using division. Now, notice that we are not just dividing polynomials. The title of this lesson is solving polynomials by using division. Specifically, when they ask us to solve, they're going to be asking us to find all the real zeros. Find all the real zeros. Okay? All right, so to warm up and prepare ourselves for this lesson, let's just review some basics. Think about those questions that you've been seeing recently on your homework assignments that ask you to write the polynomial equation that corresponds to the given zeros. We always want to write these in least degree, so in the lowest degree possible, and in standard form. Now, if our zeros are x equals plus or minus root 5, what did that used to look like as a factor before it was solved? So what did it used to look like when it was set equal to 0? Well, hopefully you remember that we kind of taught you a pattern. So this is the same as x equals 0 plus or minus the square root of 5. Okay? Now, this definitely used to be in vertex form. Okay, so anytime you see a 0 that's got a rational and irrational, we'll get into that more in detail in just a second, where you have a regular number and then one in a root that's imperfect, then that means that used to be written in vertex form. So kind of have your vertex form set up. Now the number that's in front of your plus or minus was the number that was added or subtracted with your variable x. Normally you would change the sign, but 0, there's really no such thing as plus or minus. So really you could put x plus 0 or x minus 0. And then the number that is inside the root was the number that was added or subtracted at the end. You change the sign. So if you got a positive 5, that means it used to be a negative 5 before it was set equal to 0. So let's say we had to solve this to check our answer. Let's see if this really was the original form of that would give us a solution of plus or minus root 5. X minus 0 is just x, so this is really x squared minus 5. Now if I add 5 to both sides and then I square root, I get plus or minus root 5. Some of you would be able to come up with this without even writing it in vertex form. So some of you might have seen plus or minus root 5 and thought, oh, that must have been x squared minus 5. Everyone's different. It might take you 1 minute. It might take you 1 second to figure out what the factors were or what the factored form was of that 0. But no matter how long it takes, make sure you select the correct factored form. So once I know what the factors used to be, or what it looked like before it was solved and set equal to 0, you can go ahead and multiply it out. But think about it. X squared minus 5, there's nothing to multiply out. So your polynomial is just x squared minus 5. All right, so let's use the same idea for this next 0. Anytime you see a number plus or minus a radical of an imperfect number, then that means it used to be in vertex form. So remember that the number that's in front of the plus or minus, you change the sign, and that goes in the parentheses. So that used to be plus 2. And then the number that's inside the radical also changes signs. So that used to be minus 7. Double check your answer. So add 7 to both sides. Right now we're trying to make sure that that really does give us a 0 of negative 2 plus or minus root 7. Square root both sides. And then subtract 2. So as you can see, it does give us the zeros that were originally given. Now for this one, I can multiply out that vertex form, x plus 2 quantity squared minus 7. Write the binomial twice. Foil or distribute. Every teacher is different. Some of them call it FOIL, some of them call it distribution. Don't forget about the minus 7, and then clean it up. And there's your polynomial. So we're going to need those skills for the rest of the problems, okay? Now, notice that, or remember that we've learned long division and synthetic division. Synthetic division we used whenever our divisor was a linear divisor. Long division we used when our divisors were anything higher of a degree than linear, so quadratic, whatever, cubic. But now we're not just dividing, so we're not just talking about divisors, we're talking about solving. So we're going to find the zeros. And when you're given the zero of a function, you're going to use either synthetic or long division to find the rest. Now, notice, I'm not going to give you divisors. I'm going to give you zeros. So I'm going to give you a zero, and you have to use it to find the rest of the zeros. And we're focusing only on real zeros, not imaginary zeros, okay? Now, it is recommended to use synthetic division as long as your zero, your given zero, is rational. What does that mean? It means it could be written as a fraction of integers. Now remember, integers are +1, +2, +3. It also includes their opposites, -1, -2, -3. So synthetic division is recommended for you to use whenever your zeros are rational, meaning they could be written as fractions. Long division, however, is recommended when you're given irrational. Now, the best way to kind of remember irrational numbers cannot be written as fractions, but they're numbers like pi or the square root of 7, right? 7 isn't perfect, when you square root 7 is not perfect. It's an imperfect square. So if you are given an irrational zero, you're going to use long division. How come? Because irrational zeros come from nonlinear divisors. So rational zeros come from linear divisors, whereas irrational zeros come from nonlinear divisors. Now, if I give you a zero like √5, you have to know that it came from the pair plus or minus √5. So automatically, if I tell you that √5 is a zero, you should know that so is -√5 because of the fact that plus or minus √5 comes as a pair. Same with 2 minus √3. 2 minus √3 is always going to be partnered up with 2 plus √3 because the answer, or the zeros, were 2 plus or minus √3. All right, you'll see in a little bit why that's important. Why do we need to know that irrational zeros come in conjugate pairs? So conjugate pairs means they have the same terms except for the middle sign is different. So 2 minus √3 and then 2 plus √3. Okay. Number 1, find all the real zeros of the function by using the given zero. So right away, notice that you're given a zero. You got to ask yourself, is it rational or irrational? So remember, rational zeros can be written as fractions. Well, look, -2/3 is already a fraction, so that means that it's rational. And if it's rational, that means I can use synthetic. Okay? All right, now I'm going to go ahead and set up my synthetic division. Yes, we've got a fraction, but it won't be too bad. I know people are always scared of fractions, but I'm going to put my zero. So it's already given it to me as a zero. Remember, in our previous lesson, our divisors needed to be set equal to 0 to be able to use synthetic. This one's already written as a 0. Set up your coefficients. I'm just going to double check that I'm not missing any terms. Nope, I'm not. So 6x cubed minus 17x squared minus 5x plus 6. All right, so bring down your first term. Now you're going to multiply -2/3 times 6 and put your answer in the next column. So negative 2/3 times 6 is negative 4. Now you're going to add. Now you're going to multiply. Negative 2/3 times negative 21. That'll give you positive 14, and then you're going to add the negative 5 plus 14. Gives you 9, and then negative 2/3 times 9 gives you negative 6. So the remainder is 0. Now think about what the question is asking you. It's asking you to find all the real zeros of the function by using the given zero. So the 0 they gave you isn't the only 0. Remember, this is a cubic. F of x is a cubic. We can have up to 3 zeros. Remember, max number of zeros matches the degree. So how do we find the rest of them? Well, we already found out that if I divide this function by that 0 that they gave me, if I use synthetic division for it, I get 6x squared minus 21x plus 9. So if I want to find the rest of the solutions, I need to solve this polynomial. This is a quadratic. I'm going to go ahead and just notice right away. I can see right away that these are all divisible by 3. So I'm going to go ahead and just factor out the 3. That would leave me with 2x squared minus 7x plus 3. The discriminant of this quadratic is b squared minus 4ac. Now remember, the discriminant, if it comes out perfect, it means that I can factor this polynomial. So take a minute to do negative 7 squared minus 4 times 2 times 3. If it comes out perfect, which it does, that means that we can factor. So please pause the video and factor 2x squared minus 7x plus 3. You can also use the quadratic formula by using a, b, and c. Okay, so pause the video, solve that, factor it and solve it, and push play when you're ready. No cheating. Okay, the factored form of this quadratic is 2x minus 1 and x minus 3. And don't forget, of course, the 3 that we took out as a GCF from the very beginning. All right, so remember, eyes on the prize. We're trying to find all the zeros. So when we first learned to solve quadratics and find the zeros, and it was factorable, we'd set each factor equal to 0. So if I were to set this factor equal to 0, 2x minus 1 equals 0, I'd get positive 1/2. If I set this guy equal to 0, I'd get positive 3. Now, if you're not sure how I got that, you need to set them equal to 0. So set 2x minus 1 equals 0 and x minus 3 equal to 0. It doesn't make sense to set 3 equal to 0. 3 can't equal 0. So you don't need to set the 3 equal to 0, but you do need to set all of the factors that are linear equal to 0. Okay, all that work. What's the answer? So remember, they asked for all the real zeros. All real zeros. You want to include the one that they gave you, and you want to write them in order from smallest to biggest. So the smallest 0 was the given 0 of negative 2/3. The next biggest 0 is 1/2, and finally 3. So again, when you're trying to find all the real zeros, make sure that you include the one that they gave you. So this cubic, if I were to graph it, it would hit the x-axis at negative 2/3, positive 1/2, and positive 3. So that's how you can check your answers. Graph it and see if it hits the x-axis at those values. All right, the next one gives me a rational 0. 5 can easily be written as a fraction by just putting a 1 under it. Okay, so remember, if it's rational, you can use, dun dun dun, synthetic. Okay, so set up your synthetic division. Pay attention and make sure that you're not missing any terms. Put your 0 in the box, and then start your process. Bring the first coefficient down, then multiply, add, multiply, add, multiply, add. All right, so 5 times 1 is 5. Negative 13 plus 5 is negative 8. 5 times negative 8 is negative 40. And 53 plus negative 40 is negative 13. And then negative 13 times 5 is positive 65. So you're going to have no remainder. Now this is going to be a quadratic. So this is 1x squared minus 8x minus 13. Since my goal is to find the zeros, I'm going to set it equal to 0. I'm going to take a quick minute to find the discriminant. If the discriminant comes out perfect, then I can factor it. But if it comes out imperfect, I'm going to have to use the quadratic formula. Okay. And I just realized that my 13 was positive. That's how I would get a positive 65. My fault. Do you guys see that? 53 minus 40 is positive 13. So the 13 is positive. Okay, let's try it again. So remember, the 13 is positive. So that was my fault for not catching it earlier. All right, so I'm going to find the discriminant. B squared, so negative 8 squared minus 4 times 1 times 13. I should get 12. That is not a perfect square, so that's going to mean that I need to use the quadratic formula. So remember, x equals the opposite of b plus or minus the square root of b squared minus 4ac, which we did over here. That's the discriminant. All divided by 2 times a. So then we're going to simplify. Square root of 12 reduces to 2 root 3 because square root of 12 is root 4 times root 3, and that becomes 2 root 3. Okay, then we're going to reduce and get 4 plus or minus 1 root 3. So how many zeros, how many real zeros did we get? Well, we want to write them from smallest to biggest. So 4 minus root 3 comes out to be about 2.27. And then 4 plus root 3 comes out to be like 5.73-ish. So remember, try to write your zeros from smallest to biggest. The smallest zero would be 4 minus root 3. The next biggest would be 5. And then the last one would be 4 plus root 3. I will also accept if you just write 4 plus or minus root 3 and 5. But notice that whenever you have a zero like 4 minus root 3, then its conjugate will also be a 0. Now notice that for the next two examples, the 0 that has been given is not rational. So that means that I cannot write this number as a ratio of integers. Okay, so there's no way that I can use integers to write this answer as a fraction. The square root of 2 is 1.41421, blah, 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 blah. So non-repeating decimals, imperfect squares can never be written as a fraction of integers. What's a quick way to know if you have to use long division? If you see a root that's not imperfect. If you see a root that's not imperfect, that means you're going to have to use synthetic. Or sorry, long division. Super sad. Okay, so if your 0 is an imperfect root or radical, that means that it is irrational, and you're going to have to use long division. We wish we could use synthetic, right? We got to use long division. So in order to do that, long division requires you to write this as a factor. Okay, so think back to the examples that we did at the beginning of the lesson. Square root of 2, x equals square root of 2, comes from, and remember, automatically it's going to be a conjugate. So that comes from x squared minus 2. Right? Because if you add 2 to both sides, and then square root, you get plus or minus root 2. Remember that irrational zeros always come in pairs, as opposites, or they're not opposites, they're called conjugates. So in order for you to use long division, you need to convert your 0 to a factor, and then that will be your divisor. So x squared plus 0x, notice I filled in the linear term with a 0, minus 2, and then x cubed plus 2x squared minus 2x minus 4. Okay, so I'm going to focus on the leading terms and start doing long division. X squared times x will give me x cubed. So I distribute that x to all 3 terms of my divisor, and I get x cubed plus 0x squared minus 2x. Then I subtract all of those terms. X cubed minus x cubed is 0. 2x squared minus 0x squared is 2x squared. Negative 2 minus negative 2 is not negative 4. It's 0. And then bring down the next term. Okay, so now I want to get 2x squared, and I already have x squared, so I'm going to multiply it by 2. Then I'm going to distribute that to all 3 terms of my divisor and subtract it. Subtract that product. 2x squared plus 0x minus 4. 2x squared minus 2x squared is 0. 0x minus 0x is 0. And negative 4 minus negative 4 is 0. So the remainder is 0 here. Now remember, they didn't just ask us to do long division. We had to use long division because they gave us an irrational 0. But remember, your goal is to find the zeros. So what's the last 0? X plus 2 must be set equal to 0. This guy. When we were doing synthetic division and we got our answer for the coefficients of our answer, remember, we still had to solve that polynomial that was left. So this is a linear polynomial that's left after I divide. I have to set it equal to 0. If it was quadratic, I would have to set the quadratic equal to 0 and solve it with quadratic formula or factoring. So solve this, and you get negative 2. So what is our answer? What are all the real zeros? Well, we know negative 2 is a 0. We know that negative root 2 is a 0, and so is positive root 2. Remember, those are called conjugates. And that's it. Those are the zeros. Now remember, if your 0 is irrational, Remember the dead giveaway is if you have a root that's not perfect. So like root 3 is not perfect. That means you need to use long division. And you got to figure out what it looked like in vertex form. So change the sign of the one in front of the plus, put that with the x, and then change the sign of the number inside the root, put that after. Remember, you can check your work by just solving it. So solve it really quick, add the 3, square root, and add the 1. So what this means is that if 1 plus root 3 is a 0, then automatically, and this is a property of irrational zeros, if you know that 1 plus root 3 is an answer, then automatically 1 minus root 3 is also a solution. Okay? So I already know that I'm going to have, these are called conjugates. I'm going to have two solutions, 1 plus root 3 and 1 minus root 3. So let's find the other one. Now, the factored form was x minus 1 squared minus 3. So I need to figure out what that looked like as a polynomial so I can set up my long division. Okay, so remember I had set it equal to 0 just to verify that the answer was 1 plus root 3, and that the 0. But in order for me to do long division, I need to multiply this out. Okay. So according to the steps, I'm going to use this 0 to find the rest of the zeros. I have to use long division, so I had to multiply out, the factored form. I got x squared minus 2x minus 2, and now I can divide it into x cubed minus 3x squared. Notice it's missing the linear term. Okay, and then now we do long division. So I recommend that you pause the video right now and see if you remember how to do this on your own, and then push play when you're ready to check your work. So everybody pause the video, and then unpause it when you're done with your long division. Watch your signs. And then remember here, any number subtracted from itself is 0. So to find that last 0, I'm going to set x minus 1 equal to 0, and I get a 0 of 1. All right, so we have a 0 of 1 plus root 3. You have to know that if 1 plus root 3 is a 0, then so is 1 minus root 3. Okay. So we've got 1 minus root 3, 1, and 1 plus root 3. That's all the zeros written in numerical order. Now, we will also accept 1 plus or minus root 3, comma 1. Those are okay too. The reason we ask you to practice writing them in order is because that's how answers usually appear on SATs, on final exams, and multiple choice answers. So it's just good to get into the habit of writing them in increasing order. All right, guys, as always, if you need any extra help, send us a message on Remind. Let us know, and we'll be happy to help you. All right, guys, have a good day. Adios.